자, polynomial function section 4.1, 4.2, 4.3 숙제, homework, 문제풀이 시작한다. 오케이, 여기 오른쪽 위에 해야 되는 문제들 내가 리스트 해놨는데, 오케이, 11번부터 number 11. Write each polynomial in standard form. 자, standard form이라고 하는 것은 so you have to arrange the terms in such in an order such that you have the highest degree first, and then the degree has to be in descending order. Okay, so for 11, the highest degree term is 5x cubed, so you write down 5x cubed, and then the second highest is 2x squared, degree 2, so this comes next, then 4x, then 1. Okay, so this is number 11. Number 16, well, same thing here. The highest degree term is this one, so that has to be the first term that you should have. Okay, 3 over 5, x to the 5th, and then degree 4 plus 13 over 15, x to the 4th, plus 5 over 7, x cubed, and there's no square term, x squared term, and x term, so the next one should be the constant. So that's it. Okay, let's move to the next block. Oh, let me move that thing 2 so that I don't lose it here. Okay, move it over here. Determine whether each expression is a polynomial. If so, classify the polynomial by degree and by number of terms. Okay, number 17. 자, 17 보면 is this an polynomial? For this to be a polynomial, all the degrees that you see here must be, that's degree 1. The constant term is like having 4 times x to the 0. It's degree 0, okay? So all of these powers or exponents must be the whole numbers, okay? 0, 1, 3, 5, they are all whole numbers. Then this is a polynomial. Yes, that's a polynomial. If so, classify the polynomial by degree and by number of terms. So this is what? The highest degree is 5, so this is a quintic function. And number of terms, there are 4 terms. How should I call this thing? If you have 3 terms, that's trinomial. Anything higher than 3, we'll just call it polynomial. So let's just call this thing polynomial function. Okay. And what number? 19. It has 3 to the power of x plus 2 to the power of x minus 7. This and this are basically what? Exponential functions. So this is not a polynomial function. Okay, not a polynomial function. And then what? 23. 23 is right there. Okay, you have 3 over x squared plus 5 over x plus 6. This can be rewritten as something like 3x to the power of negative 2 plus 5x to the power of negative 1 plus 6. So when you look at the exponent, exponents are what? Negative numbers, which are not whole numbers. These are basically integers. So this is not a polynomial function. 23 and then 27. We have a square root here. So you can rewrite this expression as x to the power of 1/2 minus 1. So is this power a whole number? No. Okay, this is a rational number, so this is not a polynomial. Okay. Let's jump to number 29. Oops, let me bring this thing down. Evaluate each polynomial expression for the indicated value of x. Evaluating a polynomial just means that you plug in this number to this x, plug it into these x's, and then calculate the value of the whole expression. That's it, okay? So I'm not going to do it. It's so easy. Do the same thing for 31, and no, 39 is not here. It's next block. So let's move. So what do we have to do here? Write each sum or difference as a polynomial in standard form. Then classify the polynomial by degree and by number of terms. Okay, this is just what? Sum of polynomials, just add them together. So when you do that, just group the same terms. Here's x cubed, here's 2x cubed. So add them together because it's a plus right there. Okay, so that's 3x cubed. Next highest term is x squared. X squared and 3x squared, add them together. That's 4x squared. And then x terms. X and x added together will give you 2x. Then 1 and 3. 4, okay? That's it. 43. Oh, wait a second. It says, then classify the polynomial by degree and by number of terms. Degree 3. So this is a cubic function. And then number of terms are 4. So that's a cubic polynomial. Okay. All right, this is simple, so I'm not going to go over everything. Okay, do 43 and then 47. All right, we'll move. Graph each function, describe its general shape. So I wanted you to do all the odd numbers here, 51, 53, 55, 57. At this point, you haven't learned everything about how to graph polynomial functions. So what you can do is you can use your graphing calculator or use Desmos, okay, like online graphing tools, okay. Just put this into the calculator or Desmos, and you'll end up with a graph. So for 51, when you graph it, you're going to get something that looks like this. How do we know this? This is a cubic function, and the leading coefficient is positive. So upon seeing this, we know that the right end must rise and the left end must go down. And one more thing that we should know by looking at this is the y-intercept. The constant term at the end, it represents the y-intercept. Okay, shape looks like this. 53, that's a quartic function. The highest degree is this, and leading coefficient is positive. So this means that it may have up to 4 x-intercepts. And in that case, you will have a function that looks like this, with x-axis crossing this graph like this, with 4 intersections, meaning there are 4 x-intercepts. And since leading coefficient is positive, right end will rise, left end will also rise. Okay, you have a bunch of other possibilities for something like this, and we'll get into that in later sections. 55. This is a cubic polynomial, and its leading coefficient is negative. So in that case, you will see a graph that actually a flip version of 51. So the left end must rise and the right end must go down. So you get something like this. 57, that's a quartic function, but leading coefficient is negative. So you'll get a, what, the flipped version of 53. So 57, for 57, you'll get something like this. Okay. All right, let's move. This is section 4.2, basically. Okay. Says graph each function and approximate any local maxima and minima to the nearest tenth. I said in class that finding exact location of maxima and minima, local maximum and local minimum, is not part of the curriculum here. But instead, what you can do is you can graph this using your calculator or Desmos and find out where the maximum or minimum values occur. Or what you can do is you can roughly sketch the graph by finding like x-intercepts and y-intercepts. So let me do that because this is kind of easy to factor. So for 9, px is this. So what I'm going to do is I'm going to factor out x because it's a common factor. So you end up with 2x squared minus 5. And this can be rewritten as difference of squares, just like square root of 2x whole thing squared minus square root 5 squared. So this can be factored as square root 2x plus square root 5 square root 2x minus square root 5. So if you set everything equal to 0, then this means your x-intercepts are 0. And then from here, you get negative square root 5 over square root 2. And then square root 5 over square root 2. So when you graph this thingy, since this polynomial's power is, the highest degree is 3, and the leading coefficient is positive, the right end must rise, left end must go down. And we know that its x-intercept is, no, y-intercept is 0 because there's no constant term. So it's right there. In fact, that origin is both x-intercept and y-intercept. See here, x is 0. That's one of the x-intercepts. The remaining two x-intercepts are positive square root 5 over 2. So let's say this is, that's 0, that's square root 5 over 2. And this is square root of negative square root 5 over 2. Then, since the left end must start from down here, and should pass through the x-intercepts. So you can draw your graph like this. So that right end and right end and left end follows our prediction in the beginning. The right end goes up, left end goes down. Okay. So anyway, here the relative maximum or local maximum is right there, and relative minimum or local minimum is right there. So approximate location is, it occurs what? Between this number and this number. So I can kind of guess that, okay, this local maximum occurs around this x value, which is located between this number and this number. So this is kind of middle of these two. So I'm going to take negative square root 5 over 2 and then multiply it by 1 over 2. Okay? You can do the same thing here. This x is somewhere around in the middle between 0 and square root 5 over 2. So I'm going to multiply 1 over 2, okay, to square root 5 over 2. All right, so these would be two x values where the local maximum and local minimum occurs. Okay, you can do the similar things for 11, 13, 15, 17. Okay, if you fail to factor these expressions, what you can do instead is to graph these things in on your graphing calculator or Desmos. All right. Let me see. Okay, next one says, graph each function. Find any local maxima or minima to the nearest 10th. Find the intervals over which the function is increasing and decreasing. Okay, for number 19, you can factor this one as before. So for 19, you can factor out x first. Then you have x squared minus 4 remaining here. And you can further factor this to x plus 2, x times x plus 2 times x minus 2. So the x-intercepts are, when you set everything equal to 0, x must be equal to 0, negative 2, and 2. So your graph basically looks like this. It has to pass through negative 2, 0, and 2. And its degree is 3, and leading coefficient is positive, so right hand rises, left hand drops. So you have to have a graph that looks like this. Okay, you can't actually find out the exact location of local maximum and minimum, but you can kind of approximate where this thing occurs. So I'm going to say, okay, this occurs around negative 1 here, and this local minimum occurs around this value 1. But this is not quite true though, okay? So to show you what's going on here, I'm going to draw this graph, okay, x cubed minus 4x in Desmos, and put it in here, okay? So let me put it in here. Oops. So this is Desmos output for this graph. So I try to label the x-intercepts, local maximum, and local minimum. And look at this. This is the coordinate for the local maximum. And this x value is not quite negative 1. It's negative 1.155. Okay. And for local minimum, x coordinate is 1.155, which is not quite 1. Okay. So there's a slight difference in these values. in order for you to find the exact location of this and this, the local maximum and local minimum, you need to learn calculus. Okay, so wait until then. All right, let me see. You should also do 21, 23, 21, 23, 25, 27. Okay, so just use Desmos or graphing calculator to do this if you don't if you're not quite sure how to graph this thing at this point. Okay, we'll learn a lot more about how to graph these polynomials. Okay, okay, smooth. Describe the end behavior of each function. This is quite simple. So you have to do 30 here. So this one's got, all right, power of 3, that's cubic function, and leading coefficient is negative. So your graph basically will look like this. So left hand goes up, right hand goes down. Okay, so how do you describe this? For this left hand, you say when as x approaches negative infinity, y approaches infinity. For the right hand, as x approaches infinity, y approaches negative infinity. All right, for 32, that's a what? Quadratic function with positive leading coefficient. So its graph basically is a parabola where both ends rises, okay? So the left hand, as x approaches negative infinity, y approaches infinity. For the right end, as x approaches infinity, y approaches infinity. All right, 34. That's what kind of function? That's a polynomial function with degree 6, and its leading coefficient is positive. So you'll have something like this if it has maximum number of x-intercepts, which is 6, and you know that its leading coefficient is positive, so right end must go up. It has even power, so left end goes to the same direction as the right end. Okay? So how to describe it? As x approaches infinity, y approaches infinity. For left hand, as x approaches negative infinity, y approaches infinity. Okay? Number 36. Okay, be careful. This is the what? Polynomial function with degree 6. It's kind of in the middle. It's not written as the first term of the expression here, so you have to be careful. That's power of 6, and its leading coefficient is negative 6. So you're going to get a flipped version of this one, okay? So we get something like this. So be careful, okay? By the way, I think I forgot something about this function that we did in the previous block, because it says find the intervals over which the function is increasing and decreasing. So for this function, the increasing portion is here. The function is increasing here, and it also increases here. So for increasing interval, you have to write down, okay, it's from negative infinity to what? This value right there, minus 1.155. Okay, you can either use round parenthesis or bracket. To be exact, it's bracket. Okay. Decreasing interval, increasing, there's one more interval. It's from 1.155 to negative 3.079. No, it's not that. To negative, no, what am I saying? Infinity, sorry about that. Decreasing interval, is this one right there. Okay, that's a decreasing portion of the graph. So what's the decreasing interval? It runs from negative 1.155 to positive 1.155. You can use a union symbol if you have two separate intervals here. It just means it's this interval or that interval. At KIS, your algebra teacher is basically using not brackets here, but the parentheses. So make a note of that. The only reason that I prefer to use bracket is that if you go from, let's say, for increasing interval here, if you have a value that is slightly to the left of this value, its corresponding y value will be less than this one, okay? If you go slightly to the right from that point, you will reach this point, negative 1.155. In that case, does y value increase or decrease? It still increases. So you have to include this point in the increasing interval, okay? That is why I include the end value of negative 1.155. Okay, same thing is true for this bracket and this bracket and this bracket. All right? So if you don't understand what I'm saying, you should come and ask, okay, during class. All right? Okay, let's do this one. The function y is equal to 10x cubed minus 25x squared plus x to the fourth minus 10x plus 24 is graphed at left. Okay, look at this. This looks like a typical cubic function, okay? But what we have here seems like cubic, but it's not really cubic function because what do you see here? X to the fourth. So this is quartic function. All right? That's not a cubic function. And its leading coefficient is positive 1. So what that means is that there's a portion of the graph that is not showing in this graphing calculator's window. So it says, explain how you can tell that the viewing window chosen here does not show all of the important characteristics of the graph. Find a viewing window that does show all of the important characteristics of the graph. So quartic function with positive leading coefficient here would have a shape that looks like this. So that one that's showing on that window right now is this portion. So maybe this will have something like this. It's not showing on the window. So in order for you to show this part, okay, on the graphing window is that you have to zoom out, okay? There's a function where you can choose to adjust the size of the window, okay? So if you don't know how to do that, please come and ask. I'll show you how to do it, all right?